Here I want to give a very brief example, very simple example about odds ratio, the coefficient from a logit regression, and the difficulty of making those things interpretable. Now I'm going to use our familiar example of our study session and the probability that you pass an exam. So here is if you don't go to the study session, what the probability of passing is, and if you do go. So I'm going to make up numbers here. These are totally made up. We're going to say that if you don't go, you have a 60% chance of passing. But if you do go, that rises to 75%. The probability that you don't pass is just 1 minus the probability that you pass. Alright, so the odds are defined as the probability that y equals 1 over the probability that y equals 0. So if you don't pass, if you don't go to the study session, the odds are 1.5 in favor of passing. If you do go to the study session, the odds are now 3 in favor of passing. 3-to-1 odds. So our probability has increased from 60 to 75%. Our odds have changed from 1.5 to 3. The odds ratio is 1 over the other. That's just 2. In our logit regression, the coefficient is going to be the log or natural log of the odds ratio, or 6.69. Mathematically, that is true. Now, how does this 0.69 relate to what we're talking about in terms of the probability of passing and the impact of the study session? Not very well. For me, it's not helpful to interpret this coefficient aside from the 3 ways that I will explain. Just to emphasize this, I'm going to create this data. Now, this just sort of reflects what I've written here and rerun everything that we just did in Stata here. So just to show you what we have, if you go to the study session, 60% pass. So if you don't go to the study session, 60% pass. The odds, the mean over 1 minus the mean, 1.5. If you do go to the study session, 75% pass, mean of 3. If we do our logit regression, we get a coefficient of 0.69. 0.69. So that's emphasizing where this logit coefficient is coming from. If we ask for the odds ratio instead, we get the odds ratio, the ratio of the odds with the study session and the not study session of 2. If instead we do a linear regression, actually first let's look at the marginal effects. And what this shows is the predicted change in the probability of passing of 0.15 or 15%, which is that difference here. If we do a linear model of passing on the study session, and don't forget those robust standard errors, we also get that 15% as well. In this very, very simple case where we don't have any covariates, where marginal effects and the linear model are giving us the same estimates. So that hopefully helps you think through how to interpret these results. The 3 things that we can get from base logit coefficients, like this, is the sign matters. So the fact that this is positive tells you that study session is increasing the rate of passing. If this were, say, 55%, we get a negative coefficient in our Logit regression. So the sign matters. The other thing that matters is the significance matters. These p-values are fine to interpret as we have interpreted them in different models. And the third thing that we can look at, though not in this particular setup since it's a bivariate, is the relative size matters. So if there was another variable here, maybe reading the textbook, we could compare the size of the impacts. Those are the three things that I want you to be able to think through as far as what can we get from the Logit interpretation. The fact that this is 0.69 is not particularly helpful or useful. I hope that helped to illuminate some of the questions that I've heard about the odds and the odds ratio and the Logit coefficients and how those all interrelate. Take care.